Ladies and gentlemen, welcome to GiFT. I'm Ichiro Ueda, Vice President of Hokkaido University. GiFT stands for Global Issues Forum for Tomorrow, an event that was inaugurated in 2011 and now in its third year. It's one of the flagship events of Sustainability Weeks, an event we have hosted in 2007. The Sustainability Weeks is part of Hokkaido University's annual social contributions to help create a sustainable society. We host a variety of events, research meetings, contests, exhibitions, and public lectures over a few weeks in autumn. 2013 will feature 39 events and provide a platform for intensive talks on how we can work to create a brighter future. Today's world has a variety of problems to be addressed. These are intricately interconnected. I believe education needs to equip people with these three key attributes to solve these complicated problems. First, frontier spirits to lead the way forward to a new era. Second, expertise. And lastly, extrapolations that support ability to take actions toward creating solutions. Hokkaido University makes constant effort to develop future leaders equipped with these attributes. These are our motives for holding GiFT, an event designed to guide prospective leaders who are now high school and undergraduate students in choosing a field of specialization and research themes so that we can engage in collaboration with us in the future to create a better world. Today, 6 young researchers equipped with these three key attributes will talk about current and future challenges facing the world and invite you to join their research. The first three will talk and discuss topics in the field of water management. They will also clarify key points in solutions to current and future challenges facing our planet's most vital resource. After the break, another 3 speakers will discuss issues relating to Japanese society. I believe their case studies in Japan can also provide significant insights and wisdom to other countries and regions in the world. This year, we really want you, the audience, to engage in these events by posting questions on Twitter using hashtag #HU_GiFT, or writing your questions down on forms provided. This is, after all, a forum for everyone to engage. Ladies and gentlemen, let us begin.
Good afternoon, ladies and gentlemen, or should I say boys and girls. It's my great pleasure to introduce my research area. Today, I'd like to talk about the global water issue, water shortage, and how membrane technology can save the world. First of all, I'd like to briefly explain what the membrane is like. membrane that we use for water treatment or wastewater treatment is very similar to filter paper you used to use in experiment in your junior high school or elementary school. But the membrane that we use for water treatment or wastewater treatment is much tighter and much stronger. When we look at the surface of membrane with a large magnification, you see the numerous numbers of tiny pores. And the principle of membrane separation is very simple. When you apply some driving force across membranes, such as a pressure difference, small constituent that is smaller than the tiny pores will penetrate into the permeable side, whereas the large constant that is larger than the micropores will be certainly retained. That's it. However, the size of the tiny pores is incredibly small, say less than 0.1 micrometers. So we can very easily obtain very clear water with this simple operation. When we see the market nowadays, we can see the variety of the membranes. I think you can very easily imagine these types of the flat sheet membranes, but we also have string-shaped membranes like this. We call this hollow fiber membrane. This membrane is advantageous in terms of the specific surface area. We often use some organic polymers to produce these membranes. However, recently, inorganic ceramic membranes has also become popular. And as you can guess, structures of the membranes will certainly affect the membrane performance. Here you can see the cross-section image of the membrane and the surface structure of the membrane. And one important topic here is that we have not optimized the structures of the membranes. Nowadays, we can control the internal and the surface structure of the membranes, but we don't have any consensus optimal structures of it. Additionally, we don't have any consensus about the optimal material for the production of membranes. We don't know which is better, organic membranes or inorganic membranes. So my point is, now still, production of membranes is a big frontier for researchers. Okay, so let me get back to the main story. As you have heard, well, this century is called the century of water. Why? Now we are facing the serious water shortage. You may not feel it if you live in a water-rich country such as Japan. However, water shortage is really serious and now is recognized by the world leaders. You probably know the annual Davos meeting where world leaders get together and discuss important issues. And in the recent Davos meetings, global water shortage has been a very important topic. And in this year's Davos meetings, it was said that water scarcity is the second most important world risk. And some people caution that even a war may be caused by water shortage. And here you can see the water scarcity index prepared by United Nations. In this slide, dark color indicates the area where they are suffering from serious water shortage. As you can see, water shortage is really serious all over the world. And we sometimes or often forget the importance of water. We cannot imagine our life without water. And also, we need a huge amount of water for industry and agriculture. Unfortunately, however, there is no replacement for water. So, according to one pessimistic expectation, water may become more valuable than oil in the near future. So, understandably, we need to do something to address this global water shortage. And one viable option would be wastewater reclamation, particularly wastewater reclamation and reuse aided by membrane technology. So that's why I would say membrane can save the world. And one extreme and advanced example of wastewater reclamation and reuse aided by membrane technology is seen in Singapore, where they are suffering from serious water shortage. They are trying to use wastewater effluent as a part of drinking water source. Well, to make the wastewater drinkable, of course, they need to use very advanced technology. Membrane can do that. And the wastewater treatment, wastewater treated by membrane is called their new water. And this terminology is very important terminology among the researchers. Everybody knows it. And well, this new water is very important concept, and the membrane is the key technology for the production of new water. And now, when it comes to the membrane, Japan is very strong. In the membrane market, Japanese companies are dominant, and even in Singapore, they use Japanese membranes. And Hokkaido University is one of the most important research institute for the membrane technology. But here I need to confess, well, at present, wastewater reclamation using membranes has not become common. Why? Well, there is a problem in this technology, and this problem is actually my research topic, as I will explain later. Well, when it comes to the application of membrane to the wastewater treatment, technology called membrane bioreactor, or MBR, is very promising technology. It has been drawing a lot of attention. And many researchers, including me, believe that this technology will be the mainstream technology in the near future. And I think MBR can change the wastewater management system and eventually save the world. So from now, let me briefly explain what is the currently working wastewater management system. Well, now we are using the centralized system. And here in the centralized system, we installed a big, large-scale wastewater treatment plant, and this large-scale wastewater treatment plant collects a huge amount of wastewater by using very complicated, large-scale wastewater collection network. And then it will discharge treated water into one point. This is the currently working wastewater management system. And as a result of using this centralized system, as we are seeing in the real world, wastewater reclamation and reuse is not common. Why? Well, mainly because distance between demand and supply is widely separated. Treated wastewater is only available in the area that is close to the wastewater treatment plant. And additionally, I would say the quality of the treated water is not high enough. So application of the treated wastewater is rather limited at present. Then what would happen if we can change this centralized system into decentralized system? Each small community has their own treatment facility, and the quality of the treated water is very high. For example, that might be comparable to the drinking water. Then there is no reason to hesitate to use treated water. It is free. Then wastewater reclamation and reuse will be facilitated. So by this centralized system, we can have the decentralized system. Now, question is, what kind of technology is necessary or suitable for this decentralized system? Treatment technology should be very compact, and it should be easy to operate. Automation is desirable, and it should produce the very high quality of treated water. MBR can perfectly meet these criteria. So by using MBR, we can have decentralized system, and we can promote wastewater reuse, and we can mitigate water shortage. Let me point out one additional thing, one additional advantage of this decentralized system. Well, with this kind of decentralized system, transportation of water is much cheaper and easier because the size of the wastewater collection system is very small. This means the installation of the decentralized system can be very short. This is a very important aspect for the developing countries where they need to quickly improve sanitary conditions. They cannot wait for a long time to install large-scale, complicated, centralized system. But by using this kind of decentralized system, we can quickly install the wastewater management system and we can quickly improve sanitary conditions in developing countries. So, by using MBR and the decentralized system, we can improve the sanitary condition and, well, in this sense as well, we can save the world. In spite of the advantages I have just described, well, I need to say, the use of MBR has been still limited, and decentralized wastewater management systems are still in the minority. Why? There is a problem in this technology. As you can imagine, probably, in the long-term operation of a membrane process, including MBR, some component will accumulate on and in membranes, and permeability of membrane will be reduced. This phenomena is membrane fouling. Membrane fouling will increase both operational and initial costs. So this limits the wide application of membrane technology. So for widespread use of MBR technologies, we need to address this problem caused by membrane fouling, and therefore, understandably, membrane fouling is very important and hot research topic. To control membrane fouling, we need to know what fouls membrane. Many researchers have investigated this topic, and we have a kind of consensus that, well, when it comes to the membrane fouling in MBR, some polysaccharides or proteins are the major players in membrane fouling. But there is very limited information on detailed features of polysaccharides or proteins. We don't know what types of proteins or polysaccharides are involved in the membrane fouling in MBR. So this is a problem. And, well, when it comes to the analysis of proteins or polysaccharides causing membrane fouling in MBR, I think Hokkaido University is one of the leading research institutes. One big advantage, or I would say one beautiful thing in Hokkaido, working for Hokkaido University is that this university is a very big university. So I could find researchers who are really good at analysis of polysaccharides or protein. And we did a kind of collaboration, and with the help of these professors, we could reveal the detailed information of polysaccharides or proteins causing membrane fouling in MBR. Well, I think this is probably the first report in the world. And I think by accumulating this kind of very detailed information on polysaccharides or proteins causing membrane fouling in MBRs, we will be able to develop new method to control membrane fouling in the future, and we can promote the widespread use of membrane technology. So, as I have described, membrane can save the world, I think, by mitigating water shortage and improving sanitary conditions in developing countries. Well, this research area is very competitive, but I think it's very exciting to compete with the researchers from all over the world. So I highly encourage you to join us and do research together, and let's save the world. That's it. Thank you very much.
Good afternoon, ladies and gentlemen. Today, I would like to talk to you about the ocean. The ocean that we all know, the ocean that we all love, and the ocean that, through our actions, is becoming endangered. Not just the ocean, but the life that lives there, and that we may be losing at a very fast rate. So what's the trouble with the oceans, and what are we doing concerning that? If all the world were paper and all the sea were ink, if all the trees were bread and cheese, what would we do for a drink? This is just from a child's bedtime song, but it tells you how important oceans are for us. And water is the most, together with air, is the most important component of Earth. Oceans occupy over 70% of Earth's surface and hold over 95% of all the water that exists in the world. And we just had a very nice talk about water. And we know how important it is, water. Oceans were the birthplace of life. Oceans today hold, at least we know about, over 230,000 species, and we think that there may be 2 million or more. Oceans produced, not oceans, but tiny organisms that live in the oceans, produced most of the oxygen that we breathe, and today they continue keeping that supply going on. And we all know that without that, life on Earth wouldn't be possible. Oceans regulate our climates. You know, if you live near the sea or the ocean, you see that the climate is more moderate. You don't have, so cold winters or so hot summers. But also, waters of the ocean carry from the tropics heat towards colder regions. For example, the Gulf Stream on the Northern Atlantic, we consider that the heat carried by the Gulf Stream from the polar area, from the tropical areas towards the polar areas, are probably one of the responsibles for the development of our civilization. And of course, economy. We all love nature, but we usually think more about ourselves. That's okay. So oceans are transportation means, oceans are communication means, oceans are sources of food. Indeed, 1 out of 7 people that live on the world would not be able to live without the sources we collect from the ocean. Now, what's going on with the oceans? I told you at the beginning, they are being troubled, endangered by our actions. I'm using a very simple model, so we all understand. Oceans are becoming like vinegar, and we all know what is vinegar. We use it in our kitchens for sauces and things like that. How is it going? How is it happening? CO2, we all have heard about CO2, we read about CO2 on newspapers, and we see that on TV and radio. CO2 is going out from our cars, our houses, our industries, our planes, our ships, and accumulates in the atmosphere. Then dissolves in the water of the ocean, and by combining with that water, becomes an acid, becomes the so-called carbonic acid. And this acid is acting with carbonate. Our bones, for example, are made of calcium carbonate. Most of bones, shells of the animals, spines of sea urchins, etc., are made of calcium carbonate. So this acts with it and starts dissolving. Let's just give you a little example of what is happening to the animals in the sea. Maybe some of you did it at school. I did it when I was your age. But if you didn't, you can get home and do it. Just use some of the vinegar you have it on a glass, for example, and drop some eggshell. You can also do that with a small bone. And we'll see, if you leave it for a certain time on the vinegar, you see that the eggshell starts to become very fragile. If you could see it under a microscope, you'll see that small holes appear on it. And step by step, those small holes increase. And with time, the eggshell will just dissolve in the vinegar. Exactly the same is happening with animal bones and spines and skeletons and shells in the ocean. Now, is science doing something about it? Is society and governments doing something about it? We first knew about it, when I talk about we, I mean science, around the year 2000 when, because of the CO2 accumulating in the atmosphere, governments were thinking of, well, maybe we can just dump it into the ocean and get rid of it. And then scientists started doing experiments. They started enriching seawater in laboratories with CO2 and looking what happened to those animals and plants that lived in there. And they noticed that skeletons started to dissolve, reproduction started to, be late or be stopped even, growth started to decrease. And that's when all of this question about the so-called ocean acidification started to come on. People like me, here at Hokkaido and in many other places, we work with sea animals. In this case, it's bryozoan, kokemushi in Japanese. It's an animal, a colony, that looks like a plant, as you see there. It has a skeleton made out of calcium carbonate, exactly like my skeleton, exactly like your skeleton, exactly like the eggshell. So what I do is that I put these animals in the lab, in bottles enriched with CO2, and I see what happens. What happens to their growth? And what happens to their growth is that with time, growth decreases and even stops. And what about the skeleton? Well, the above picture is a normal skeleton. And you look at what happens to the below picture. Skeleton starts to dissolve. But reproduction also stops in many cases, and physiology and a few other. These are just the more evident results that we are obtaining. The other thing that we do is that we use collections. Whenever you go to a museum and you see a beautiful exhibit there, think that that material of the exhibit is used by scientists to compare what was before, because those collections may maybe have 100 years or 200 years, sometimes more. So you can compare those animals, those plants with what you have today. And you can see those changes happening. Let's talk a little about Japan. We are here in Sapporo, beautiful city. Well, Japanese waters, oceans surrounding Japanese islands, hold almost 15% of all the diversity in the oceans. This makes up a little over of 33,000 species that are here. So it's a big responsibility. Now, is Japanese society, Japanese government doing something about oceans acidification? Yes, it is. Quite a lot, as a matter of fact. One of the things that you can have access to it and you can see the state of the art, so to speak, of ocean acidification. It's this Japanese Meteorological Society website, which records all the progress of ocean acidification, not just surrounding Japan, but also in other parts of the world. Graphs like this, for example, you can see there. For example, you see that one way we measure ocean acidification is through the so-called pH. And pH varies between 1 and 14, being that 1 is the most acidic and 14 is not acidic at all. So if you look there, you have the pH, and you have years from 1980 through 2010. And you see those graphs, you see how pH is decreasing, which means if pH is decreasing, acidity is increasing. Remember, as low pH, as higher acidity. And then on your left side, you have also a transect of the Kii Peninsula. In the Kii Peninsula, on the last 26 years of measurements, we noticed that acidification had increased by 0.04. Well, you say, well, 0.04 is nothing. It is something, because during the last 200 years, acidity increased by 0.1. Now, make the math, make the calculations. 200 years, 0.1. 26 years, 0.04. In the next 200 years, the acidification will be much higher than had been on the last 200 years. And that's one of the biggest problems, is the speed at which it goes. And that's why we think, and we are sure, as a matter of fact, that it's human action that is doing that. That's exactly. Another program that the Japanese government has and that I'm working on and is several projects, big projects, working on animals and plants, and also developing tools. We need better tools in order to know better what is going on in the ocean. Searching for solutions. The Kyoto Protocol, I'm sure you all heard of it. It went in action in 2005. It will expire this year, and there is no replacement. Governments in the world had not become to a solution to replace the Kyoto Protocol. Well, maybe Japanese society, that was one of the initiatives of the Kyoto Protocol, maybe can take the lead, and maybe should take the lead about this. And it's really important to have a replacement. Now, what about us? You know, the ones that are here, the ones that will maybe listen to this, or are, you know, noticing about through Twitter and other mechanisms. Can we do something? Yes, we can. We can always do something. First of all, we can use better the resources of the ocean. Second, maybe we can use bikes and walk instead of using the car, so it is less CO2 going to the atmosphere. Maybe we can heat a little less our houses. You know, I also like to be comfortable at home. But still, think about all the CO2. Think that we are the future, and the ocean is here, was here, and we want it to be continuing here for the future generations. If we want to save it, all of us need to have our little grain of sand in order to have a big beach. In this case, a little drop of water in order to have a healthy ocean and all the life that lives in it. Thank you.
Good afternoon, everyone. Welcome to my talk. And today I'd like to share some of my thoughts on how the scientists in my field can contribute to addressing issues concerning conservation of biodiversity, especially in river systems. Okay. As we all know by today, we are facing the fastest rate of species extinction at the global scale in modern society, modern history. And the freshwater ecosystems, including rivers, are one of the most endangered types of ecosystems on the planet. Okay, this figure came from the US, and as you can see, a greater proportion of species are facing a risk of extinction compared to other types of ecosystems, such as terrestrial ecosystems, right? The reason is very simple. Okay, you can think of why the rivers are more sensitive to the human activities. They accumulate and they receive most of the impacts of our influences from the human activities that take place in upstream catchment areas, right? And Japan is also under a great threat of biodiversity loss, and particularly because we have a high population density in such a small country at the global scale. So it is a great challenge for us to strike a good balance between the need of protecting nature and the need for development of land and also the prevention of disasters, right? So in this context, I am committed as a scientist to address 3 critical questions, right? So first, we need to know why and how species diversity or endangered species matter to us. The answer to this question would provide us a good logical reasons to invest money and time for protecting them. Secondly, we also need to know the root causes of environmental degradation. So with the knowledge about what is causing degradation, the managers or we can do a better job to come up with ways to fix the problems effectively and efficiently. Right. And third, we also need to know where the remaining important ecological functions exist in our society, world. Right? Ecological functions refers to the processes that are important in maintaining populations of particular species. That's what I mean here. Right? With this information, we can prioritize sites or locations that need to be conserved or protected with high priority. So we can do a better job in our conservation or protection of nature. Right. So, I'm sorry. So this is how we do our research. I'll just give you time. Right. So reading rivers, by which I mean understanding rivers, okay, through the field-based observations. That requires us to feel what the target organisms feel, or to see what the target organisms to see. That way we can better understand how the system works. Okay? And we also use almost anything that we believe would help us to read rivers, including not only fish. We also look at the bugs, insects, and plants, sediment, soil, and so on. And also a variety of knowledge from different disciplines, including biology, geomorphology, hydrology, hydraulics, will be very useful when reading rivers. So now I'd like to introduce some research results briefly, corresponding to one of each of my critical questions. So firstly, I and my colleagues tried to evaluate the cultural benefits provided by rivers. So what we did is we counted the number of people visiting rivers for different purposes. Okay? And at the same time, we counted number of species of fish in each river. We surveyed almost all large river systems across our country, which was more than 100. And what we found is that in rivers where we see higher species richness of fish, there are more people using those places for different recreational purposes, such as fishing or for just having fun. Okay? What this tells us is that there's a chance that if we lose a species richness, then there's a risk that we're going to lose some cultural benefits we receive from river systems. Right. So talking about the second example, this is about freshwater mussels. These mussels are one of the most endangered groups of organisms on the planet for many reasons. And the managers and we are very much concerned about how we can protect their habitat and how we can restore their habitat. But unfortunately, throughout the world, including Japan, their habitat is shrinking substantially. And this is the one of the typical habitat in Japan. What do you think about this river? Well, it has a green vegetation along water course, and the water quality is not very bad, but the habitat is shrinking. Well, we try to find out what's going on in this river, and we had to go back to the condition in the past. So we have to look back the past condition to find out what was wrong with this river. So over the period of about 30 or 40 years, the landscape level appearance changed substantially. Okay. Basically, we have more vegetation now compared to the past condition, which may sound good to you, but it's not. Right. The other way of looking at reading this river was looking at the topography of riverbed, okay, which cannot be easily seen from the ground. You have to go under the water. And what we found is there's an unusual rate of erosion going on underwater, which cannot be explained by any natural processes. Okay, and this was about like 20 meters deep, which cannot happen in nature. So then putting all this information together, we came up with the conceptual model and also the scientific rigorous analysis, we concluded that construction of dams and also the extraction of sediments from river channel in upstream area was the main cause of the ecosystem degradation in downstream areas, right? So with this kind of information, we and river managers now at least know what is causing the degradation. So there's a clue for what they can do to restore or conserve or protect their habitat, right? So third example, this is about commercially valuable species, salmon. Right. This is the life history of this salmon. Okay, they hatch from the egg in rivers, and then they migrate down to the ocean. And after spending several years in the ocean, they come back to lay their eggs again. This is their life cycle. Incubation period of eggs is critical for their life cycle, and water environment having a particular temperature is critical for their successful development, right? So by the end of this, by doing this research, what we found is simply saying there's a places where we receive a lot of, they receive a lot of influences from groundwater coming up from the riverbed, right? So this is where we did survey. Toyohiro River, you're familiar with this? And the Toyohiro River flows through the center of our Sapporo city, where nearly 2 million people live. So you can imagine how much human influences this river can receive. But amazingly, in some locations, this river is still receiving a substantial amount of groundwater recharge from the riverbed, which again cannot be seen by just by looking at the river from the ground. And this water coming from these locations are very unique, and they are different in terms of water chemistry and also temperature regime compared to the stream water. And then what we found is the locations where the salmon, they spawn, they lay eggs in cold winter period match exactly with the locations of these groundwater places. Okay. So which tells us that, conservation of the groundwater system that provides a good habitat for salmon is very much important, critically important probably for maintaining their winter population. Right. So here's another important message from me. Publishing papers is a necessity to survive as a scientist, as our professors told me repeatedly in the past. But I'm increasingly recognize the importance of practicing our cutting-edge information, scientific knowledge to the public. Right? So there are many ways, but one way of doing that is providing environmental educations to the public. Okay? That way we can teach what is going on in our surrounding environment very effectively. So in my lab, at least, I urge most of my graduate students to participate in those kind of activities as much as possible and share the knowledge with the general public. In conclusion, I'd like to stress 3 points regarding the management of river systems for future. Right? First of all, we should respect nature. Rivers, they know how they can support a variety of organisms. So we should set up the system in which rivers can do what they want to do as much as possible. And also secondly, protecting, conserving everything is impossible and impractical. So we should prioritize our choice. So try to find out what is important compared to the others so we can do a better job. And at the end, science can help us. Okay? There's a still large gap in our knowledge about how the river system works. So that needs to be filled up. So we need to carry on our research. So if you are interested in doing this kind of work, I welcome you all warmly to join our team at the Hokkaido University. Thank you very much.
Okay, so the Q&A session is going to begin now. Can I just invite the speakers back onto the stage, please? Can you give them a round of applause? There we go. We've had quite a few questions from the audience come in, so thank you very much for that. I'll start with a question that's come from the audience for Dr. Kimura. In terms of the okay, so how safe is the water treated by MBR for drinking, like heavy metals and organisms and things like that?
And thank you for the questions. And the membrane that we use for the membrane bioreactor is tight enough to completely reject the microorganisms. So we can assume the water that is free from bacteria, but well, when it comes to the heavy metals, I need to say MBR is not enough. So if heavy metal is the concern, then we need to apply other process to remove the heavy metals.
I see. In terms of the end result, you're expecting it to be drinking water again, is that correct? I mean, a lot of people sort of, in terms of what's called recycled water, perhaps turn their nose off because it is perhaps, I mean, it might be 100% pure, but have you looked at the sort of that aspect of people wanting to be able to drink the actual water?
Sorry, my explanation was not enough in my presentation, but to have the drinkable water from wastewater, well, I would say MBR is not enough. We need to add additional, much more tight membrane process. We call that reverse osmosis. And the reverse osmosis membrane process can remove, I would say, everything from water, including, well, sodium, very small ions. So actually, maybe you know that the reverse osmosis is used for the desalination from seawater. This process also can be used for the wastewater reclamation, but for the treatment of the reverse osmosis, for the wastewater treatment, first we need to, well, purify the wastewater at some grade. For this purpose, MBR is perfect. So we call that the kind of hybrid membrane process combined with the MBR and reverse osmosis. And this is actually what I used in Singapore's case. So by combination of the MBR or reverse osmosis, well, I would say you can produce a drinkable water from wastewater, and I can assure the safety.
I see. Just a question. I mean, you've mentioned Singapore. Are there any other case studies? This is a question from the audience as well. How can it be available in third world countries?
Good question. At present, I would say no, because of the high cost. However, well, now what we are seeing is the rapid declining of the both initial and operational cost of the membrane process. So I hope in the near future it might be available for the third countries, third world.
Okay, thank you very much. We've got quite a few questions here to get through. I'll turn over to Dr. Fortunato now. Here is a question. Why the ocean at the lower latitude showed lower pH because of human impact in the area?
Thanks for the questions. Well, oceans, it could be because of the concentration of people there, but also it has to do with the currents that, the water. The ocean is really an universal, so what you dump in here, it may show, in several years, say, on the Caribbean side, which, it's pretty far away from here. But you can also have impacts like temperature will also, and at lower latitudes, water is warmer. So with temperature, higher temperature, the solubility of the ions increases. So that could also be one of the reasons why you have lower pH on lower latitudes. We really don't know. You know, oceans are so old, much older than we are, but it's not our environment. So in order to go there, you saw the little movie by when reading the rivers, you need special equipment. If you go to the ocean, you increase that equipment. So it's difficult to study oceans, and there's a lot that we don't know, and that's one more reason for concern, is that things are disappearing that we don't even have a clue what they are.
This question is perhaps from a concerned member of the audience. Is the level of acidity harmful enough to humans swimming in the ocean at the moment?
No, no.
No.
Probably it will never be, hopefully, because if we you know, the little example I gave you with the vinegar and the eggshell was just for you to have an understanding, a better understanding of what is going on with skeletons. It's still a long process. It's not from a minute to the next one, so it's not that you jump in the ocean and you start having holes on your body. When that happens, we will not be here, for sure, because then everything else had been gone from the world. But we are getting to a dangerous situation.
Okay, thank you very much. And our last, our first speaker of the day was Negishi Sensei. Now, there's a question here. What was your latest opportunity in which you practiced your knowledge? I think you were basically, you know, referring a lot to how you go out in the field a lot and read the sea. Read the rivers, sorry.
You mean occasions in which I practice my knowledge? Is the I had a lecture. It's not a lecture, but in the middle of Hokkaido, there's juniors or elementary schools where the nature is very rich. It's called Shimukapu village, and there we provided. Environmental program it's about 1 month ago with the students, and there we learned about what the freshwater fish eats, and then how the environmental conditions surrounding area can affect the habitat for fish, and that's what we taught to the elementary school kids over there. So that's the latest opportunity for me. Yes.
All right. Another question that came through is a local sort of concern about Toyohira River. You mentioned you were researching salmon population in that river. What else have you found out? I mean, it goes right through the center of Sapporo. Is it a healthy river?
Water quality wise, it's good. It's very clean water, but the problem is right now is because of the dam in upstream area again, and rivers need a sediment coming from the upstream area to support a riverbed to be at a certain level, elevation. But because of the dam, no sediment is coming from the upstream area. So humans, we have to put the artificial structures to artificially maintain the level of riverbed elevation. And thinks it's not going to be better at all. So in like few decades, we're going to have more serious problems that I can say for sure. But we don't know what to do with that yet. So that's another concern.
That's another one. Okay, and perhaps a last question, because we have to move on. To join your research, should we be able to swim well?
Yes. I'm a good swimmer.
It's in here. So, there you go. Okay. Well, that concludes the session. We'll see you here back at 3:30 sharp. Could you please make sure that you're in your seat by 3:25? I know that only gives us a short time, but yeah, thank you so much.